Hey everybody, this is Miss Berry. In this video today, we're going to go over section 1.2 from our textbook, which is called, Properties of Exponents and Radicals. So this section is a little bit longer than I had anticipated, but I think there's maybe 5 topics that we have to talk about. So I'm going to flip the camera around and we'll start going through the material. If I can remember how to do this. There we go. All right, so I'm recording this in Teams because I like the way Teams works. So that's why you see a Teams tab open there. So here's my whiteboard. It says section 1.2, properties of exponents and radicals. The first topic that we need to talk about is integer exponents. And we have a couple of definitions here to go through. Let me just specify here that these are definitions. So definition, if A is a real number and N is a positive integer, just as a side note, positive integers are sometimes called the natural numbers. Or sometimes called the counting numbers. Because those are numbers we count with, positive integers. If A is a real number and N is a positive integer, then the symbol A to the N represents the product of N factors of A. Now that's just a fancy way of saying that we're going to multiply A by itself N times. So the way that this looks is we have A times A, that's a dot there, A times A times A times dot 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 A equals A to the N. So this is repeated here N times. Now, it looks a little complicated when you have N in there, but let's use some actual numbers. If we have 2 to the 3rd power, that would be 2 times 2 times 2. So 2 multiplied by itself 3 times. 2 times 2 is 4. So 4 times 2 is 8. Now, you don't have to do this in your head. You can use your calculator. I have my calculator pulled up right here. Let me see if I can get both of these guys on the screen at the same time. There we go. Just clear that out. All right, so you could do, if you're using your graphing calculator, which is what I have here, I'm going to just press the 2 button, and then I'm going to use my little caret button there that's going to take me to the exponent. So exponent, and mine, I have a TI-84 plus, so it's the syntax is a little bit different if you have a TI-83, but it goes up into the exponent there, and I can put the 3 there. Then I always like to arrow out of the exponent, so just arrow over 1 time, takes you out of the exponent, and then hit enter. 2 raised to the 3rd power is 8. Now, this 2 to the 3rd power is easy, but if you had something like 2 raised to the 32nd power, definitely something you would want to use your calculator for. Rather than trying to do that in your head. All right, so that's our first definition. When you have an exponent that just represents repeated multiplication. Here's our second definition. It says if A is not equal to 0, then we define A to the 0 as 1. Okay, and it's important here that the base cannot be 0. So 0 to the 0th power is undefined. So that's why they specify there that the base can't be 0. So we're not dealing with this case here. But for example, any number raised to the 0th power is 1. So even if you had something like x to the 0, as long as you knew that x was not 0, and then you could say that x to the 0 power is 1. Okay, and then our last definition here for this topic says if A is not equal to 0, and if N is a positive integer, then we define, this one says A to the negative N equals. Now, I know this looks a little complicated because I just said the N is positive. The reason they specify the N is positive is because imagine if n was a negative number like -2, then it would be -2, and two negatives cancel each other out and become a positive. So that's why they specify that n has to be a positive number. So if you have a raised to a negative n, then we have a special rule that lets us turn any negative exponent into a positive exponent just by moving it either to the numerator or to the denominator. So in this case, we're going to assume that this is all over 1. So if you move this term to the denominator, it's going to change the exponent to, it's going to change the sign of the exponent. So that becomes, in the bottom, you would have 1 times a to the n, and what's left in the top is just 1. So let me erase this first part, just so it looks a little neater. So a to the negative n is equal to 1 over a to the n. All right, so let me show you a little example of that. Let's say, I'm going to use a different color. Let's say we had something like x to the negative 2 over, let's just say 2. All right, and a lot of the questions on your homework, actually, I think I would say all of the questions are going to say, write your answer in terms of positive exponents. So they never want you to use negative exponents in your answer. So to accommodate for that, we're going to have to move this term down to the denominator. Now I'm going to put it after this constant 2. All right, so I'm going to have the 2 down here. Then I'm going to have the x. Now, all that changes is just the sign on the exponent. So that's going to become a positive 2 instead of a negative 2. And then what's left in the top is just 1. So that's how you can make any, you can change the sign of any exponent by either moving it to the denominator, or if you had something like this, let me scroll down a little bit. If you had something like this, maybe you had y to the third over, cut off my tail there, y to the third over b to the negative 4. You could move this to the numerator to make that exponent positive. So the y to the third would stay in the top. It's positive, so we don't need to change anything to do with that term. But b to the fourth, that's going to move to the top. That becomes a positive 4. Now in the denominator, it's just 1. Anything divided by 1 is just itself, so you don't even have to write divided by 1. That would be your final answer. All right, so now you know how to take any exponent and change its sign. All right, so let's look at some examples of this topic, which was, what was it, integer exponents. All right, so we have just 3 examples here, just really 2, and this one has 2 parts. So we have simplify -5 squared. The way you would do this is you would say, okay, well, this is the same thing as -5 times -5. Oh, I just made a mistake. Oh, gosh, you guys, that was a close one. That's a very common mistake I was about to make. Now, this negative is on the outside. Now, if it looked like this, -5 inside the parentheses squared, that would be -5 times -5. That would be positive 25. This negative is on the outside, so you're just going to stick that outside. Don't worry about it for right now. Then we have 5 times 5, because it's 5 squared, 5 times 5. 5 multiplied by itself twice. That would be -25. Whew, that was a close one. Almost messed up. We're just at the beginning of the video. All right, so you could also do this in your calculator. Let me pull that back up. It looks kind of small. Let me see if I can. Oh, I just have to move it down to zoom in. Duh. Okay. Let me focus it again. All right, so your graphing calculator at the very bottom down here, the very bottom, if I can show you, see that little button right there? That's the negative button. It's right underneath the 3. So you could have -5 squared. We have a special squared button. You can just do the exponent again. I guess I'm a little too close. So you can see that little special squared button is diagonal from the 7. So -5 squared is -25. Now, just like I said before, if you put that in parentheses, negative 5 squared is positive 25. So it's very important to note whether the problem has parentheses around the number. So that indicates that the whole number negative 5 is being squared, whereas on this one it's saying square 5 and then make it negative. So that's the difference. Okay, here we have a couple of examples using our second two definitions that we learned. All right, so it says simplify, write your answers using only positive exponents. All right, so we have x to the negative 5. We already know that you can just move that right on down to the denominator. Be a 1 left in the top. That would be 1 over x to the 5, x to the 5th power. And we know that as long as y is not 0, that anything to the 0th power is 1. I really should have specified here that y is not equal to 0, but I forgot. All right, so that's our first topic. Our second topic talks about properties of exponents. So you may want, this is in your textbook, of course. I took all this out of your textbook, but you may want to pause the video, take a second to write these properties down, unless you're following along with the guided notes, and then you can just follow along from there. This is going to be stuff that you either want to have memorized, or you may be able, depending on which class you're in, you may be able to use like an index card or something like that on the test. So make sure you, ask me before and see if I let you have any kind of little cheat sheet for the test. I'm trying to make this video like in general so I can use it in later semesters. All right, so we have 6 properties of exponents. A lot of these you probably just know even without thinking about it. This first property says that if you are multiplying two numbers and they have the same base, so you can see both of these have a base of a, then you add the exponents. And then they have a little example here. I'm going to write my own little example to the side. Let's say you have x squared times x. We know that this is just an understood one here, so you would add the exponents since they have the same base. That would be x to the 3rd power. We have a similar property if we are doing division instead of multiplication. So if you have a to the n divided by a to the m, if these two numbers have the same base, you would subtract their exponents. And it's always the exponent in the top minus the exponent in the bottom. So here's an example here. 7 to the 9th power divided by 7 to the 10th power. So that would be 7 raised to the 9 minus 10, which is negative 1. And we already know that that would simplify to, remember we would just move it to the denominator. That would be 1 over 7 to the 1st power, which is just 1 over 7. All right, then we have our property that we just learned. So we already knew this one. A to the negative n equals 1 over a to the n. So we just learned that one. This one, I like to call this one a power to a power. That's how I will refer to this one. So we have a to the n raised to the m. So we have a power being raised to a power, or an exponent being raised to an exponent. If you have a power to a power, then you multiply them. So here we have an example, 2 cubed raised to the 2nd power, or 2 cubed squared. So you would do multiply those exponents. 3 times 2 is 6. So 2 to the 6th power would be 64. This one right here, I would call this distributing the exponent or the power. So if you have more than one term inside of your parentheses, like here we have a times b raised to the nth power, you got to make sure and distribute that exponent to both terms. So that becomes a to the n times b to the n. This one is super easy to forget to do when you have a problem like this. So like you have 7x raised to the 3rd. It's so easy just to raise x to the 3rd power and then forget to do the same to the 7. So make sure that you distribute that exponent to both powers. You have 7 cubed times x cubed. So 7 cubed would be 343. X cubed, that's in simplest form. All right, and then we have another one. This one is also distributing the exponent. It's just distributing the exponent with a division inside instead of multiplication. So if you have a fraction on the inside, you have a divided by b raised to the nth power. You just got to remember to distribute the exponent to both terms. That would be a to the n over b to the n. And again, here we have 3 over x squared. So you got to make sure you got to square the 3 and you got to square the x. So 3 squared over x squared would be 9 over x squared. So a lot of properties, but like I said, some of them you already know, and a lot of them are very similar. All right, so let's see. It says, here and throughout the lesson, assume that every expression is defined. So that means if you have an exponent is 0, then the base is non-zero. And if the expression appears in the denominator of a fraction, then that expression is non-zero. So if you have 0 in the denominator, that's undefined. And remember that a to the 0th power is equal to 1 for every value of the base, which is not 0. So that was one of our definitions that we learned at the beginning of class. All right, so here we have some examples of the properties of exponents. We're going to go through these and look at some examples. A lot of these came straight off your homework. All right, so we have simplify. Write your answer using only positive exponents. N to the 5th times n to the 7th. I have the same base and I'm multiplying, so I'm going to add my exponents. So that would be n to the 5 plus 7. You don't have to write this in between step if you can do this in your head. So that would be n to the 12th. All right, we have a similar situation here. These are being multiplied. We have x to the negative 2 times x to the 4th. All right, so we have the same base, so we're going to add the exponents. So we have x to the negative 2 plus 4. Negative 2 plus 4 is 2. It's the same thing as saying 4 minus 2. So that would be x to the positive 2. All right, let's see. Oh, I threw this one in just to, I wanted to tell you, if you do not have the same base, you can't combine these. So the only thing we can really do here is just try to take care of this negative exponent. So we're going to pretend like this is all over 1. We're just going to move this term to the denominator. The x squared is going to stay in the top because it is, it's positive. So there's nothing wrong with that one. So this will become x squared over y to the 7th. Okay, I'm going to have to mute my video real quick because someone keeps calling me and I think it's a call that I have to take. So I'll be right back. I'll just call him back later. Okay, that was going to take way too long. Okay, so I have my next example says a to the negative 2 raised to the negative 3. All right, so this is a power to a power. It's a little bit different here because they're negative, but that's okay. You know, when we have a power to a power, we multiply the exponents. So that becomes a to the negative 2 times negative 3. Negative 2 times negative 3 is 6. So that would be a to the 6th power. Negative times a negative becomes a positive. All right, now we're getting into some of the more complicated examples. Try not to, you know, don't panic. We're going to take this step by step. It looks harder than it actually is. All right, so let's look at this problem. Here we have y to the negative 7th power times y to the negative 2 times x squared, all raised to the 4th. In the denominator, we have 3y to the negative 2 being raised to the 4th power, and then x squared. I'm going to work on my parentheses first, and that's how the order of operations works. So I'm going to just go ahead and distribute this exponent to begin. So we have y to the negative 7th, not doing anything with that yet. I'm going to go ahead and distribute that. So that's y to the negative 2 to the 4th power, and then x squared to the 4th power. And then I'll go ahead and distribute this exponent on the bottom as well. So that would be 3 to the 4th. times y to the negative 2 to the 4th, and then x squared. Notice how if it already had an exponent, I'm just putting it in parentheses, and that way it looks like my power to a power formula. All right, so we have, let's see here, that's going to become, I think I might just do some work in between here to save myself some writing. Negative 2 times 4, power to a power, you multiply them, so that would be negative 8. 2 times 4 is 8. And then here, that would be negative 8 as well. And then if you want to, do you want to plug that in the calculator? Let's see what that's going to be. 3 to the 4th. 3 raised to the 4th is 81. All right. So we could go ahead and say, okay, well, we know that's 81. All right, now let's continue in our problem. Just kind of write what we have. Y to the negative 7th times y to the negative 8 times x to the 8th divided by 81 times y to the negative 8 times x squared. Okay, so there's a couple of different things you could do at this point. What I'm going to do is I'm going to go ahead and combine the stuff in the numerator. We have y to the negative 7 times y to the negative 8. I know that if I have the same base, I would add their exponents. All right, so let's do that. Negative 7 plus negative 8, and then x to the 8th. In the bottom, I do not have any anything to combine. None of my bases are the same down there. So I'm just going to rewrite that. I'll take care of that negative exponent in just a second. All right, negative 7 plus negative 8. That's negative 15. So let's go ahead and write that in. Or we'll just move it on over here. Y to the negative 15, x to the 8th, over 81, y to the negative 8th, x squared. Let me scoot my screen over. All right, now we still have some work left to do. We have, we need to combine these. So sort of ignore everything else for a second. And we're just going to look at like this part of the problem, y to the negative 15 over y to the negative 8. We know that when we have the same base, we would subtract the exponents, and it goes y to the negative 15 minus negative 8. So negative 15 minus negative 8, that becomes negative 15 plus 8, which is negative 7. Okay, so that goes in the numerator. So y to the negative 7, x to the 8th. Now this part's gone. We took care of that. Then we have 81x squared. So we're also going to have to combine those. This one's a little bit easier. We can kind of just, actually going to just throw a sticky note on here. I'm going to cover up this for a minute. All right, so x to the 8 divided by x squared, 8 minus 2 would be x to the 6th. And again, that goes in the numerator. Okay, so that would be y to the negative 7, x to the 6, 8 minus 2 is 6, over 81. 81 stays down there in the bottom. It doesn't have a negative exponent. We don't have to do anything with it. All right, the last thing we got to do is take care of this negative exponent. So go ahead and move that little fella down to the bottom. That becomes x to the 6. That is what is left in the top. And then in the bottom, we have 81. I like to put the constant first. 81, and then y to the positive 7. So we moved it to the denominator. So now the exponent changes sign. And there's our answer. Everything's got a positive exponent. We know how we don't have any like terms that need to be combined, so we know we're done. So I know that was a lot. You know, you may need to pause, go back and rewatch to get all of this. All right, I'm going to go on, look at our next example. All right, so we have our last example, part F, for this topic is negative 3a divided by b to the negative 2, all squared. Much simpler than our last problem. We're going to have to distribute this exponent. So distribute the exponent to everything. So we have, now watch what I'm going to do here. Negative 3 is inside the parentheses, so we're going negative 3 squared. It's important that you write it like that. A is being squared. Don't have to worry about A, it doesn't have a negative on it. And then we have b to the negative 2 is also being squared. Okay, so let's work on this. Negative 3 times negative 3. It's negative 3 squared, so it's negative 3 times negative 3 is positive 9. A squared stays A squared. Then we have a power to a power, so we're going to multiply them. We have negative 2 being raised to the second power. Negative 2 times 2 is negative 4. We got to take care of that negative exponent. So just take this whole term, just boop, move it up to the top. That's 9 a squared b to the positive 4. Okay. I'm going to, I'll do this video in 2 separate parts. So I'm going to stop here for this video, and then you can come back and watch part 2 to get the last 2 topics. So look out for the section 1.2 lecture video part 2. Thanks, everybody.